At home, we all have a circuit breaker. It's that trip switch that protects our electrical installation in the event of a short circuit. In an electric power plant or a substation, Alstom circuit breakers play the same role. They allow the current to flow in the case of normal functioning, and they automatically interrupt the current in the event of a short circuit or an overload. But how do they work? The circuit breaker relies on the separation of two electrical contacts. Instead of protecting 220 volt circuits as at home, Alstom circuit breakers work with much higher voltages. At that level of power, when two contacts separate, an electrical arc is formed. The art of circuit breaking resides in the mastery of this arc. This requires precise control of temperature conditions and of the distance between the contacts. To achieve this, the separation of the contacts is carried out in an arc chamber. In this arc chamber, there are fixed contacts and mobile contacts, and pressurized gas. In general, the gas used is sulfur hexafluoride, or SF6, which is twice as resistant to the passage of electricity as air. Under normal conditions, the current flows through the permanent contacts, those at the periphery of the device. In the case of a circuit break, we begin by separating the permanent contacts. The current then concentrates in the contacts situated at the center of the arc chamber. Composed of more solid material, capable of withstanding electrical arcs, they are called arc contacts. The central contacts separate, thus forming an electrical arc between the arc contacts. The temperature inside the arc chamber becomes intense. The gas molecules explode, and the SF6 loses its insulating qualities. Another consequence of the heat, the pressure of the gas increases. The movement of parts in the arc chamber also contributes to this rise in pressure, just like in a bicycle pump. Under pressure, the gas escapes from the center of the arc chamber towards the bottom of the chamber, drawing the arc with it. The electrical arc is extinguished. This gas is replaced by cooler gas in the central zone. The SF6, thus cooled, rapidly recombines and recovers its insulating capacities. Everything is calculated very precisely. In 50 milliseconds, the contacts are separated. The circuit break has been sure and fast. Alstom offers a range of circuit breakers adapted to all electrical transmission needs, including the world's most powerful circuit breaker, Alstom's PKG. It can safely and rapidly interrupt currents of up to 275,000 amps.